So today we are going to be looking at quadratic inequalities. But before we get to quadratic inequalities, we should recall how to solve linear inequalities. Okay. So here is a basic linear inequality. And the technique we learned to use last time was to first solve it for x, adding 3 to both sides, divide by 2. We have to remember that if we divide or multiply by a negative, we switch the inequality in this case, but just precaution. And then we graph the solution set. So x is less than 3 halves. We put 3 halves here. We don't include 3 halves because we don't have an include symbol. This is a strict less than, not a less than or equal to. And then we include all the numbers to the left. So we use a line to represent including all those extra numbers. We then write our answer or our set of answers in interval notation. So this is interval notation representing all those numbers. This is the graph. This is the solved equation. So this is how we solve linear inequalities. Alright, so today we are going to learn a different technique that is going to follow 4 steps. Last time we learned that technique, it followed 3, solving it, graphing it, and then expressing the answer. Today we're going to learn a different technique, and it's going to have 4 different steps. The first thing is that we're going to change the inequality to an equal sign. The next thing is we're going to solve for x as though it is an equal sign. We're then going to graph the points that we found in the second step, whether they're open or closed, based on the inequality. And then last, we're going to test the region or intervals. So these steps will make more sense when we do a couple of examples. So let's do an example. So let's start off with a linear inequality, show how this technique works, and then we'll move on to quadratic inequalities. So the first thing we're going to do is we're going to change the inequality to an equal sign. This isn't the normal way we would solve a linear inequality. We would normally just solve it and then graph it. But we want to solve quadratic inequalities, so we're learning this new technique. So we then solve it like it's an equal sign. Move the x over, -1, simplify, and we get a single answer. We now graph this one number, -4, because this is an open inequality. That is, it's a strict less than. It doesn't include the equal sign. Then we're going to put an open circle where we graph -4. Okay. Notice that when we graph that one point, this real line here is kind of split up into 2 parts. This part and this part. Okay. So there's 2 sections to the real line. So what we want to do is figure out which section is the solutions to this inequality. They could both be solutions, neither of them could be solutions, or everything could be a solution, well, except -4. So what we need to do is test each of these intervals. Now it turns out that if one of these points in this entire interval is a solution, then everything here will be a solution. And if one point here is not a solution, then nothing here will be a solution. This cuts down our work, so we only need to test one point from each interval. So let's take -5. We test it in the inequality. So this is -9, and this is -8. This is a true statement, which means that -5 is a solution, so everything here is a solution. So we now know what the graph looks like, somewhat. Now technically we aren't done, because we have to test the other side too. It could hypothetically be possible that the other side is also a set of solutions. Generally that won't happen, but sometimes it does. This is false, so none of those are solutions, and we now know the set of solutions for this inequality. And now we can express our answer in interval notation. -infinity to -4, open parenthesis. Okay? So, let's try an example with a quadratic. So here's a quadratic. We know it's a quadratic because it has a degree of 2.